Good morning. In this online class, I would like to do a quick revision on case study Challenger Space Shuttle disaster. Okay? In my previous online class, I did a revision on case study Bhopal gas tragedy. Now, we are going to do a quick revision on case study Challenger Space Shuttle disaster. Okay. Generally, the Part C questions in your university examination question paper may be direct questions from any unit, or Part C question may be general questions related to any unit, or Part C questions may be case studies questions. You all know about it. Generally, the case studies, well-known case studies, or case studies like Bhopal gas tragedy, Challenger disaster, Chernobyl disaster, 3 Mile Island accident are mostly discussed in textbooks. Okay. So these are the well-known or popular tragedy, disaster and accident. So when you go through any standard book, so you might have found out these case studies. So generally this 4: Bhopal gas tragedy, Challenger disaster, Chernobyl disaster, 3 Mile Island TMI accident. But not necessarily these 4 case studies ought to be asked in the examination. You may expect any other disaster, any other tragedy or accident, or any general case studies. So you must prepare accordingly. Okay? For your information, case studies questions were asked in Part C in April, May 2018 and November, December 2019 examinations. Also in November, December 2015 examination, case study question was asked in Part B. So this is for your information only. You can go through the previous semester university exam question papers. You can find these case studies questions. Okay. In these case study questions, generally you have to explain the tragedy, disaster, accident, whatever it is, you have to explain. Sometimes furthermore you are asked to discuss the violation of moral, ethical and professional code of standards in the tragedy. Also, you may be asked to write conclusion to avoid such tragedy in future. So the question may be anything, or you may be asking you to do anything. But generally, the questions need the students to explain the tragedy, or explain or discuss the violation of the ethical, moral and professional code of standard in the tragedy. Also, sometimes you may be asked to write the conclusion. So when you prepare these case study questions, so you must have what is that accident, how it happened. So that generally you must know. Then what are the problem, what are the violation, what are the technical fault, what are the moral violation, what are the ethical violation, that one you must know about it. Then when you write conclusion, how this tragedy could have avoided, or how to avoid this tragedy in future, that one you must give review. The case study questions, you have to apply whatever you learn in all the 5 units in this subject. You have to apply the technical terms, then procedure, philosophy, or principle, concept. That one you apply properly. Then you give your own view and observation nicely. In this video, I am giving some idea, some structure about the case study and its solution. But not necessarily you follow that one. You take the idea, you can improvise, and any question comes from this type of disaster, you write nicely. We already discussed all these case studies in detail in the class itself. Course materials, that is slides and case studies related materials have been given to you all. Go through them in detail, please. So let us have a quick revision on case study Space Shuttle disaster now. Okay, I am going into details about the Space Shuttle Challenger disaster. I hope you all have a fair idea about the Space Shuttle Challenger disaster, because I already taught you and we discussed the disaster in the class itself. I gave all the course materials and case studies materials to you. So I hope you all have a fair idea and knowledge about the Space Shuttle Challenger disaster. Here I am going to do a quick revision on the case study Space Shuttle Challenger disaster. Okay, keep that in mind. The Space Shuttle Challenger disaster was a fatal incident in the United States space program that occurred on Tuesday, January 28, 1986, when the Space Shuttle Challenger broke apart 73 seconds into its flight, killing all 7 crew members aboard. The crew consisted of 5 NASA astronauts, 1 payload specialist, and a civilian school teacher. The mission carried the designation of STS-51L and was the 10th flight for the Challenger orbiter. Actually, the shuttle mission was plagued by problems from the beginning itself. Mostly the problems due to weather conditions and technical conditions. Okay, shuttle mission STS-51L delays. The Challenger was originally scheduled for July 1985, but by the time the crew was assigned in January 1985, launch had been postponed to late November to accommodate changes in payloads. The launch was subsequently delayed further and finally rescheduled for the late January 1986. So launch delays. Liftoff was initially scheduled on January 22, 1986. It slipped to January 23, then January 24, reset for January 25, rescheduled for January 27, but delayed another 24 hours. The Challenger finally lifted off at 11:38 a.m. EST 28 January. From this slide, you come to know there was a number of times postponement, delays in launching the Challenger. Okay, moving to next slide. The first delay of the Challenger mission was due to a weather front expected to move into the area, bringing rain and cold temperature. So, the first delay of the Challenger was mainly due to weather. Okay. Then moving to next slide. Second launch delay was caused by a defective micro switch in the hatch locking mechanism and problems in removing the hatch handle. Once these problems had been sorted out, winds had become too high. So weather front has started moving again, appeared to be bringing record-setting low temperature to the Florida area. So second launch delay was due to the technical problem. So there was a defect in the micro switch in the hatch locking mechanism. So they solved the problem, they rectified the problem. After the problem was rectified, then again the weather problem started. The winds had become too high. Okay, so because of that, the launch was delayed. Okay, then I'm moving to the next slide. Okay, mission details. Challenger was scheduled to carry some cargo, that is Tracking Data Relay Satellite 2, TDRS-2, then another one, Shuttle Pointer Tool for Astronomy, or Calis Comet Experiment deployable to observe the Calis Comet. Okay, now we can see the basic shuttle design. You can see in this slide there are three important components of the shuttle. You can see number 1, orbiter, number 2, external turn, number 3, solid rocket booster, SRB. There are 2 solid rocket booster. One is left solid rocket booster, another one is right solid rocket booster. So there are 3 important components: orbiter, external turn, solid rocket booster. Okay, so now we are moving to next slide. So first one, orbiter. So it is the primary component. A reusable winged craft containing the crew and payload that actually travels into the space and returns to land on a runway. So that is orbiter. So length 37.2 meter, height 17.25 meter, mass 68.5 tons, payload 32,000 kilogram, cruise maximum 7. That is orbiter. Okay. The next component, just now we see in the figure, external tank. The external tank carries liquid oxygen and liquid hydrogen in 2 separate compartments. This is the fuel that is fed to the 3 orbital engines. So the external tank ET is jettisoned at an altitude of 111,400 meter and burns up over the Indian Ocean. Okay. Then the third component, solid rocket booster SRB. Without solid rocket booster SRB, the shuttle cannot produce enough thrust to overcome the Earth's gravitational pull. An SRP is attached to each side of the external fuel tank. Each booster is 149 feet long, that is 45 meter, and 12 feet, that is 3.6 meter in diameter. After the SRBs have lifted the shuttle to an altitude of about 150,000 feet, then solid rocket boosters are jettisoned using small explosive charges. The SRBs then deploy parachutes and fall into the ocean. They are recovered by tugs. So now you can see in the slide furthermore details about the solid rocket booster. Each SRB joint is sealed by two O-rings. The bottom ring known as primary O-ring and the top known as secondary O-ring. The purpose of O-ring is to prevent hot combustion gases from escaping from the inside of the motor. Putty to provide a barrier between the rubber O-rings and the combustion gases. A heat-resistant putty is applied to the inner section of the joint. You can see the diagram. You can see the figure. There are two figures given. One is field joint before ignition. Another one is field joint after ignition. You can see that. So this is the typical space shuttle mission profile. When the shuttle was launched, space shuttle was launched, so SRB was jettisoned. SRB was jettisoned. You can see the jettisoned at an altitude of 45,760 meter. Okay. Then ET, external tongue, is jettisoned at an altitude of 111,400 meter. So this is a typical space shuttle mission profile. Okay. Temperature on the day of launch. So the air temperature had dropped to -8 degrees centigrade the night before and 2 degrees centigrade on the morning of the launch. No previous flight had been attempted below 11 degrees centigrade, and the manufacturer Morton Thiokol had insufficient data on how the boosters would perform at lower temperatures. Although the Thiokol engineers were concerned about launching under these conditions and recommended a delay, many felt that the booster should be able to operate safely even at that low of a temperature. The problem started here. You notice that air temperature dropped to -8 degrees centigrade and morning 2 degrees centigrade, but the manufacturer had no idea about how the boosters would perform at a low temperature. But others feel that it will be all right, you can perform everything okay, even at the low temperature also it perform well. So some kind of so misled the launch. So here it is one of the reason for the failure. So please take note. So we can see this figure. Wind flowing over the ET and impinging on the aft field joint of the right SR beam. So this is cold condition pre-launch. So you can see the ice layer on the ET. So cold conditions pre-launch. It is common procedure for ground personnel to use infrared cameras to measure the thickness of the ice that form on the ET external tank prior to launch. By chance, ice team happened to point a camera at the aft field joint of right SR beam and recorded a temperature of only minus 13 degrees centigrade, much colder than the air temperature and far below the design tolerances of the O-rings. Had this wind been flowing in almost any other direction and not impinged on the aft field joint, it is likely that O-rings would have been considerably warmer and disaster may not have occurred. So here also you can notice one important point. The ice team, their job is to measure the thickness of the ice that formed on the external tank. They notice the temperature. It was minus 13 degrees centigrade, 18 degrees Fahrenheit. It is much colder than the air temperature, also far below the design tolerances of the O-rings. They noticed, but their job was to measure the thickness of the ice only. Okay, now I'm moving to next slide. An additional factor was that information collected by the ice team was never passed on to decision makers, primarily because it was not the ice team's responsibility to report anything other than the ice thickness on the ET. So that is unfortunate, because the ice team job was, their responsibility was to measure the thickness of the ice that formed on the external tank. But they noticed the temperature. They noticed the temperature minus 13 degrees centigrade. But they could not pass on the information to decision maker. So this is also one of the reason for the failure. So you can please take note. Had the aft field joint temperature been provided to engineers at NASA and Morton Thiokol, the launch almost surely would have been aborted, the loss of Challenger avoided. If the lowest temperature, that information was passed on to the decision maker, that is NASA and Morton Thiokol, then this disaster could have been avoided. But it did not happen. It did not happen. Okay. Also the warning. The Roger Boyce-Jolly, a Thiokol engineer. The Thiokol only manufacture the design. So Thiokol engineer, they are the manufacturer. So the engineer had gone on the record the night before the launch. So Roger Boyce Jolly, a Theocol engineer. Theocol is the manufacturer, the company name. So the Theocol engineer had gone on record the night before the launch. In a teleconference with the NASA, he stated, "If we launch tomorrow, we will kill those 7 astronauts." He was ignored. So his warning was not taken into consideration. So his warning was ignored. So that also one of the flaws in the disaster, the launch, and it led to disaster. Okay, the countdown and launch. The Challenger was counted down and lifted off at 11:38 a.m. EST, 28 January 1986. Unfortunately, the shuttle exploded 73 seconds after liftoff, killing the 7 crew members. Okay. So, safety lessons from the Challenger disaster. So, the disaster happened. So, when we go through all the events, all the recordings, all the whole stories, so we can learn some safety lessons in the Challenger case. It involved many risky situations. So we can take it as this is a conclusion to this case study. So one can learn safety lessons from the Challenger disaster. What are the safety lessons? The safety lessons: 1. Negligence in design efforts. The booster rocket casing recovered from earlier flights indicated the failure of field joint seals. No design change were incorporated. Instead of 2 O-rings, 3 rings should have been fixed. But there was no time for testing with 3 rings. At least 3 rings should have been tried while launching. Okay. Next lesson or next point: test on O-rings should have been conducted down to the expected ambient temperature, that is to 20 degree Fahrenheit. No normalization of deviances should have been allowed. This is also an important point. The third point: NASA was not willing to wait for the weather to improve. The weather was not favorable on the day of launch. A strong wind shear might have caused the rupture of the weakened O-rings. So next point: final decision making of launch or no launch should have been with engineers, not on the managers. So engineers insisted on safety, but the managers went ahead with the schedule. So another important point: informed consent. The mission was full of dangers. The astronauts should have been informed of the probable failure of O-rings, that is field joints. No informed consent was obtained when the engineers had expressed that a specific launch was unsafe. So next point, that is a safety lesson: conflict of interest, that is risk versus cost. There were 700 criticality 1 items, which included the field joints. A failure in any one of them would have caused the tragedy. No backup or standby had been provided for these criticality 1 components. Then Another lesson, escape mechanism or safe exit should have been incorporated in the craft. So these are the some safety lessons one can learn in the Challenger case, involved many risky situations which are. So this is taken as a conclusion to this case study. Okay. I just give you a general approach or general format for the only for the in this video. For this type of case studies questions, you no need to follow exactly what I give here. Sometime mostly, as I already told in the early part of this video, as far as the case studies questions are concerned, you might ask to explain the disaster. You may be asked to discuss violation of moral, ethical, and professional code of standard in it. You are asked to find out what are the problem flaws in that one. Also, sometimes you may be asked to write a conclusion about how to avoid the disaster or what are the lessons learned from the disaster, something like that only. So mostly based on that only you have to approach the case study. Keep that view, that aspect in your mind, you have to give your answer. So, as far as the case study questions are concerned, you follow these points. You can add your own, your views, your observation, technical points. So, violation of moral, ethical, professional code of standard in it. So, because you studied all the 5 units in the professional ethics in engineering, so all these 5 units give you some idea, some knowledge. You gain some professional excellence from the 5 units. Lot of terms, a number of concepts, a number of managerial aspect, philosophies. So you apply that knowledge to in these case studies questions. So you can use appropriate terms, concepts, and relevant points which you learn from all 5 units of professional ethics in engineering. Make the question neat one. You can add some more. So take this video as a eye opener. So you can improvise your answers. So refer my materials, study or go through a standard book. See this video also, and any questions comes on case study, write nicely. Okay, write accordingly. What is the question? You read the question. What are the content they want? So write accordingly. Okay. Bye. Thank you.